Guys, ScannerDanner here with my son Caleb behind the camera as usual. My name is Paul Danner, not Dan. It's really, really bright and it's a little windy. We're working on a Ford. It is windy. That's gonna definitely be an issue. So I apologize for the wind noise up front. This is a Ford F150. I'm not sure the year yet. All I know is Pete told me it has a fuel rail pressure sensor fault code and that the fuel pump had already previously been replaced. So that's all I know. I asked him if it drove bad, like low power or anything like that, and all he said was it idles rough. He's not really sure. So really, we should test drive this, but let's see what we have first. We'll go from there. Okay, 2006 Ford F150 with a 4.6 liter engine. That's what we're working on. We're just interested in what the engine's doing right now. I'm not worried about a full code scan. We'll do our memory codes. So we got a map or baro pressure circuit intermittent, fuel rail pressure A circuit fault, fuel rail pressure sensor A circuit range performance, P1000 code means someone was in here and cleared it. Then we have O2 sensor excess lean signal on bank 1 sensor 1, O2 sensor signal stuck rich on bank 2 sensor 1. That's interesting. So we have a lean and a rich O2 code. A map, baro, intermittent, fuel rail pressure circuit A, fuel rail pressure sensor. All right, so let's look at some data. See if I can find my O2's fuel trim and fuel pressure data on the same list. I might not be able to. There's fuel pressure percentage, fuel rail pressure desired. It's 54. That's DSD. This is desired. Fuel pressure percentage. That'd be the command for the pump. Fuel rail pressure voltage and fuel rail pressure in PSI. Keep those up top. I'm interested in my short term and my long term. Let's customize this. Okay, scratch the custom list for a second. I want to see what my map sensor's showing me. The 29.2, that sounds right. 156 frequency on the baro. That's old school Ford stuff as far as how their map sensors worked, that they give that to you in a frequency reading. Let me start it real quick and look at that number. We want to see map voltage drop, so that looks relatively normal. Okay, exiting out of there, let's go to our trim. Okay, fuel trims are up top. Desired pressure is 39.7. Fuel rail pressure is 39, right in that range. I thought when I told Pete we'd take the job that we were dealing with a gas direct injection system. We're not. This is an old school design electronic returnless fuel system. These trims look fine right now. Snap throttle test is initially okay. Let's see what this fuel rail pressure's doing. I don't like that drop. That dropped down to 12 PSI. That's a little bit delayed. We shouldn't be dropping that low on our fuel rail pressure. This might end up being a pump, in which case power and ground tests are going to need to be done. If the pump's failing, we can definitely get lean condition right on that 102. The other one said rich, but what can happen there is that you can end up with fuel commands that are add fuel, add fuel, add fuel, add fuel, add fuel, right? Because of low pressure. And then if the pump comes back, then you have all that addition of fuel and now we got to take it away. It's possible that long-term and short-term countering each other. We set that rich code on bank 2, possible. The map and baro out of range code can be just from low power, poor idling conditions, maybe starving for fuel. You can certainly set a map code. That's not unprecedented. So all of this could be tied together. I didn't anticipate this being as simple as, hey, we just maybe have a bad pump. Let's see if we can speed this data process up. So if you look at this number down here where it says 355 and counting, I'm gonna customize this now and let's see if we can speed this up. Yeah, see how much faster that's counting now? So that will allow me to do more accurate snap throttle testing. Some exhaust leaks. but that's dropping to 22 on a snap. You will have some drops in pressure on these electronic systems because your rail pressure's up here, rail pressure sensor's up here, and then your duty cycle controlling the pump for speed, and those commands, there's a delay in the reaction of a speed increase and decrease on the pump compared to what you read on the rail. I really need to drive this, Caleb. I don't like that it's dropping to 20 PSI under a snap. So on this test drive, we're gonna focus on our oxygen sensor 1.1, our 2.1, those are our upstream O2s. We're also gonna focus on our fuel rail pressure, that guy. I'm gonna cover this, so the top left is my fuel rail pressure data parameter. I'll just leave it like that because I wanna see my fuel pressure percentage at the bottom, okay? So I'm interested in a volume test here with this pump. We're gonna do a wide open throttle test. You guys have been following along. This is a nice fuel delivery test. We go wide open throttle, we look at our oxygen sensors. We should be rich the whole time we're at wide open throttle. We don't want to see these O2s drop lean. That's what we're looking at. The nice thing on this truck is we have rail pressure that we can look at. So we can look at fuel pressure the same time we're doing this test. And yeah, that's what we're about to do. So we get ourselves to a safe area where we can do a wide open throttle run. And what I'll generally do is I'll come to a stop. I just really want to wind out first gear. I don't need to speed, right? Let's watch it. Pedals to the floor right now. Right there was good. We were rich the whole time. So this is an intermittent fault. So I'm gonna come to a stop. There's nobody behind me, no traffic around me. We're gonna watch the O2s and watch our fuel rail pressure again. I'm at wide open right now. Fuel pressure's not dropping, and we were rich the entire time I held it at wide open. That's what we want to see. So right now, our problem is not there. I anticipated when we started that we were going to be dealing with a fuel rail pressure sensor problem because, you know, the pump's new and just figured somebody maybe made the wrong call there. But the fact that we had lean O2 faults on bank 1, I realized bank 2 showed rich, but lean O2 faults combined with map and barrow, intermittent, and fuel rail pressure range performance, this could easily be a failing pump, and we just need to get it a little bit warmer. There's a little wide open throttle one right there, and we were rich the whole time again. I was not anticipating this being an intermittent fault. Intermittents are tough, man. It's like, we got to prove it. If the new pump that was put in here is faulty, which today's parts is a very, very real possibility, I don't want to just guess and say, yeah, throw a pump at it. I need to make it do it. Kind of look at our trim numbers while we're waiting too. So let me ungraph that. So my fuel rail pressure is now just digital right underneath the oxygen sensor. And then we can look at our trims. These trims look fine right now. I honestly am not worried about an over-fueling condition, even though we had rich conditions on bank 2. I just believe that is an effect of what was going on with this truck as far as the fuel rail pressure being out of range, the map and barrow code, and the lean code. I think those three go together easily. All right, this is a nice long hill. Once we get past some of these residential homes, I'll do a nice wide open throttle run here. Nobody's behind me. What I'll generally do, again, because I don't want to get myself in any kind of trouble just looking at scan data and going really fast, in particular, being safe. So I just came to a stop. There's wide open throttle. Be safe. O2s are rich the whole time. I'm still at wide open. Fuel rail pressure's keeping up, no problem. Rich the entire time. That is super frustrating to me right now. Just from a standpoint of the fault that this truck has is not there right now. I think this is the model that has the fuel pump control module on the frame. Do you remember the one we did? Was it a Ford van where the module was, the wiring was all jacked up on the fuel pump control module? Do you remember? I see a broken wire. This has been replaced before. See the green cruddies? Yeah. And then this broken wire here. Yellow with a gray. That's the one that's broken. Yellow gray is our fuel pump power. And then the white, looks like white and brown's all messed up too. White and brown is my fuel pump monitored signal. Yeah, this is it. So it might be worth it for us to go back and take a look at this fuel pump control module and just see, see what it looks like. See if there's any dinged up wires or if it looks corroded. Because like right now, this thing's working exactly like it should. I don't see any issues with our fuel trim on either bank. I know on this data list, we're not looking at the map sensor. I'm not worried about that map or baro code. That's gonna be an effect too. If this thing starts falling on its face and we lose fuel pressure, we're gonna set a map code. That's very, very common. One of the things that I teach, in fact, in chapter 8 in my book, which is listed as pressure sensors. So when I go through that with my class, when we talk about pressure sensors, one of the first things that I have written down is for a map sensor, for a map code, you want to ask yourself, is the map sensor causing the engine to run poorly, setting a map code, or is the engine running poorly, setting a false map code? It can be either one. This being a mass airflow engine, generally we don't see with this a map sensor causing the same type of drivability problems it would be if this was a speed density engine, meaning no mass airflow. But the question is still valid, which is when you see a map code, is the engine running poorly, causing that map code? Or do you have a map sensor problem that's making the engine run poorly? In this circumstance, in what we're dealing with these other codes, it is the engine running poorly that's setting a map code. I'm sure of it. And so I'm not even looking at the map sensor right now. That was a long explanation for why I'm not looking at the map sensor or worried about that data PID. Now, if I have that data PID available on this list, I would pull it up, but I do not, and these other PIDs are more important to me in recreating this fault. So in case we don't have the opportunity to show it, I'll have my son Caleb here pull in right now in the edits what fuel starvation looks like. I'll find a video that has the best view of oxygen sensors, wide open throttle, vehicle falling on its face from a lack of fuel using this O2 wide open throttle test. My 1-2 shift. Didn't even look at the scan tool yet. I just glanced down. O2s were definitely lean. Let's pull over and take a look at this data. All right, so right away, what I'm seeing here, guys, this is a wide open throttle condition where we're lean. So vacuum leaks do not affect the wide open throttle operation of an engine. This particular capture is not a vacuum leak. This is data that tells me we have a fuel delivery problem. Mass airflow, fuel pressure, those are my top two that I'm gonna check. So my engine speed, you see as I'm accelerating, as this is climbing, you see my O2 is lean on bank 1, and the O2, this is frame 620 I'm looking at, 620, frame 620 on the bank 2 sensor 1. You see how lean we are on bank 2 as well. So both banks are being affected. So pretty cool test, right? It's a great guide. It's a great guide in where you're going with any low power condition. Wide open throttle, look at your O2 sensors. So two things we're gonna do now. Number one is we're gonna talk to Pete and see what other kind of info we can get from him. And then the second one is going to be, we need to look at this fuel pressure control module, which I think is on the frame. I think we'll do that first rather than bug Pete, because this thing's running perfectly fine right now. Okay, I'm gonna leave it run. I'll grab a flashlight and I'll crawl underneath this. These numbers look great. I see absolutely nothing wrong with it. I changed my mind. Let's go talk to Pete, because I gotta get some cardboard to lay on the ground and then see if we can get some more data from him. This Ford, it runs fine.
So
Give me a history.
It died, I guess, and didn't start up.
Okay, good.
So it was like it happened before, and we put that fuel pump module in there about 5-6 months ago. Then it was good.
So the module or the pump itself was replaced?
So the module that's in the back by the gas, by the spare tire.
But the pump was never changed.
No, the pump was never changed.
And it's fine right now. So the module's new.
New, yeah, but I've seen them go bad before.
Sure, absolutely.
You know, I think we did one.
We did. We were just talking about that on an E350. There was a van.
And there was one, I think Roy's over there, went up to your brother's. We put one on, went up there, and it ended up being bad again.
So we think possibly module again.
Yeah, it could be.
I got to prove it.
Yeah, I just didn't want to change it.
Yeah, I'm with you. But okay, so it died even after the module was replaced.
The tow truck drove it off the truck, parked it.
Okay, let's see what I can do. All right, that works.
Sorry, Paul.
But the pump was not changed. The module was changed.
Yeah, the pump module.
Okay, got it.
The ones that get corroded in the back.
Yep. Okay. That kind of sucks a little bit. I was just hoping for something easy. And we're just gonna have to make this do it. Like, these are tough. When you get intermittents like this, it's tough because you don't want to just throw parts at the problem. Maybe I'll get lucky and I can wiggle some wires and stuff, and you know. So what I'm gonna look for, kind of focus on our fuel rail pressure. That guy, I'll do some wiggling, see if I see any damaged wires anywhere. I'm just kind of looking for points of contact on this harness. Did I hear him right that it was good for 5 or 6 months?
I don't.
Just need something to smack on it with. Damn it, it's not what I was hoping for. I want conclusive. What is this circuit here? That's my pump ground. I believe that goes to the frame. Yeah, that goes to the frame up here. This pump ground. This rusty frame, I should add. Yeah, I'm just kind of looking at fuel rail pressure to drop off, or my fuel pressure percentage to jump up, looking at the O2s to drop lean. If I start dropping fuel pressure, I'm gonna see that. And I don't have any of that going on. And this ground is tight, but you know, I'm wiggling it but without any change. You know, we could easily have a pump going bad. Damn it. Okay, I'm gonna get out of here. I was thinking we could look at fuel pump current. The problem with that on these is this pump's being duty cycle controlled, meaning it's being turned on and off rapidly, and it really makes the waveform very muddy, very difficult to look at. And I was just thinking of some case studies I've done in the past where you can identify an armature that is bad on a fuel pump based on the waveform, on a current waveform. And I had a customer with an intermittent no start problem. It would never die on him while he was driving it, but it would intermittently not start. And it would just happen to be whenever the fuel pump would turn and stop on that one dead spot on the brush, then it wouldn't start back up again. You can identify that kind of thing. It's important to know how to do, but with this pump being duty cycle controlled, makes it more difficult. I'm gonna ask Pete again. I think he said 5 months. I wanna ask him again.
Yes, sir.
Hey, did you say that it was good for 5 months after you changed it?
Yeah.
5 months.
I don't know exactly 5. I don't know.
I mean, but it's been good for a while. Like, and his symptoms before were the same. Was it intermittent? Like it died on him?
Uh-huh.
Okay, so you said it died on him while he was driving it, or was it a no start like in the morning?
I can find out. That's Scott Urquhart's son.
Yeah, if you can find out just to help me duplicate it, that'd be great.
Okay, let me call him right now.
All right, thanks, Pete.
All right, bye.
All right, bye. Not that it's gonna really matter for us here, but this is your fuel rail pressure sensor. 3-wire sensor, 5-volt ref, signal to ground. You would test these exactly like any other pressure sensor. No difference. But that's not gonna be our issue, especially given the symptoms. So just to revisit our fuel rail pressure, when we did our snap throttle test, I was like, man, we shouldn't see that kind of drop down to 20 PSI. But then I mentioned there's a delay because of the way this system's designed. Let's just see what it looks like sitting here, if I can kind of recreate that. Yeah, I can. See those dips down to, what's that lower number? 18.5. So that's why we test drove it, because I can then hold it for a longer period of time at that high RPM when we have that fuel demand, kind of like what I'm doing here when I'm snapping the throttle, is we're increasing fuel demand on that pump because our injectors are spraying. But that momentary drop is not a problem. It's the sustained demand. As long as it can keep up, then you're good, and we were able to on the road. Now, honestly, for where we are now, it's a roll of the dice. You want to throw a pump at it, or you want to throw another module at it. Of course, there's wiring too you got to worry about, and I'm not willing to do it. That's not troubleshooting. This is one where we need to drive it, and we need to be prepared for when it dies to have a tow truck, if it's a pump, because I'm not going to be able to get that going again, or have some multimeter leads with us at least. While we're waiting, I guess there's one other thing I can show you. It's easy to do because the module's right there. Let's do the fuel pump current draw measurement. I'll just show it to you. It would be awesome if I could see some kind of armature problem. Scope multimeter, we're gonna use some presets for this. Lab scope, low amp 20. That's a real low scale. Let's set that to 10 amps. As far as this amperage reading goes, without checking diagrams, knowing system design, this pump module controls the pump power and ground, and I know that that's my ground wire. So I'm just simply gonna connect this around my ground wire for my module, which should be my fuel pump current. What are we looking at? Not anything near what I would expect it to be. Let's invert this. That is a super low amperage waveform, but again, this is a system that's controlling the pump speed to control pressure, and there's not a lot of fuel demand right now. It's like not anything that would jump out at me. It's a much cleaner waveform than I anticipated. I don't see any dead armatures in this. You kind of look at this waveform, they're tough to pick out sometimes as far as repetition of the signal. We could try. We could look at that weird one and look for it again. I don't see it. Let's go to the next frame. See if we can see some repetition here. This one here looks like an M. It kind of looks like that one there. What do you think? Yeah. So then you count your humps in there. Typically it's 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That'd be a 10-bar pump. But the point with this test was not getting lost in the number of commutators. It was more to look at one that maybe was open, that could give us an intermittent no start. Here's a picture from my book this is chapter 17 or 18, where I'm teaching this to my class, and I'm showing them that case study that I talked to you guys about, where the only way I could identify this problem, you see the dropout in this armature signal. There was no other way I was going to be able to identify that without having a low amp capture of this pump, because I could have drove that truck all day long. It would have never acted up. You would have to drive it and then shut the truck off, and the pump would have to stop right in that dead spot for it to not start back up. And that was one where it would never die on the customer. It was only an intermittent no start. And that's why my question to Pete was so important right now. Is it dying on him driving it, or is it only when starting up? And this is where my head was when I asked that question. But taking this waveform kind of tells me, yeah, it's not going to be that. This thing probably did die on him when he was driving it, most likely. If we're in this area, it's not going to be a dead armature. Yes, this amperage is much lower than I'm used to looking at. A typical multi-port system, you're looking at amperage that's 4, 5, 6, even higher. My truck, for example, is like 9 or 10 amps. That's a Chevy Silverado, but it's running at full speed all the time. This one is being pulse width modulated. I think, let me see if I can change pressure on the scan tool and show you a higher amperage. Our amperage average is between 1.5 to 2 amps, roughly, right? Scan tool, let's see what is offered to us in the form of fuel pump on and off, and duty cycle. Sweet. Wait, this thing's not acting right. Some of these bidirectional tests, I can't put all of my eggs in one basket. Yeah. So let's look at these two guys. If you guys remember, with the car running, we were about 20%, right? And we can look at desired too. So desired down here, actual here, and then the duty cycle command. So there's 30%. You see immediately it changed it to 75 actual, and that was only a 20% change. So it looks like the desired is not changing. This is what the computer wants it to be at as far as driving conditions. I can't really use that because as I'm changing my percentage, my desired isn't changing. You see the rail pressures reacting to the percentage change. That's a little weird. Basically, I'm not changing the desired pressure. I'm changing the pump duty cycle. That pump gets noisy. Did you guys hear that? When I go 100%, the pump just drops off. That's very weird. So I'm kind of forcing this pump to go max on me. There's 75. At 75, man, I should see a much higher amperage signal here. Am I? Yes, I am. Okay, cool. Sweet. There's 4 amps of current, 4.5, right? That's a pretty standard looking pump pattern right there. Here, we'll get a little bit more for you guys. There's 50 milliseconds, right? Yeah, sweet. That's what I wanted to see. I was like, wait, why is my amperage lower? That's at 75 PSI. That's where we are, amperage-wise, on that pump. So that kind of answers that question, is why is our fuel pump current so low? Because it's a pulse width modulated pump. We're controlling amperage through this pump to control speed, to control pressure, and that is why our amperage is so low. Completely normal, completely normal. I do like, though, that I can stress this pump. This is better than any test drive that I could do as far as pump stress goes, is this test right here. Very, very valuable. Listen to the pump. Hear that? I don't know that that's necessarily a problem. Yeah, when I go above 50, it just doesn't like it. It essentially like shuts the pump circuit off. All fun stuff, right? Except we got to make a call. we gotta make a call. Is it the module that's failing on us intermittently, or is the fuel pump failing on us intermittently, or are we losing power back here intermittently? I would put my money on a bad part. That guy right there. If I was gambling, because of how often these fail and because of the parts that we are being sold nowadays, that my money's on that guy. In fact, because I'm saying that, I want to get something to tap on it with. I don't have any of my tools with me. I'm going to tap on it with a screwdriver. Be right back. All right, so remember 20 is about where we were. Just watch your fuel rail pressure over here at 35. We don't need the amp clamp anymore. We're done with that. Just hoping I can make this pump fail. I don't want to beat on it too hard because, you know, I don't want to make a module fail just by, you know, if I smack it hard enough, I can make it fail, right? I'm just really trying to simulate road vibrations more than anything. And I'm tapping on the frame right here. I can hit that hard. Don't want to hit this box that hard. Dude. That sucks. Smack the tank. I've never been able to make a fuel pump fail by doing that. You can get them started again by doing that. I hate to be like, we're done, but we're kind of done. I'm not prepared to make a call. There's no other checks I need to do. Some of you might be thinking, well, what about a power or ground problem back here? It's a good question. The amperage that we saw, that rise in amperage with the command, addresses that problem. The fact that we can get 75 PSI out of this pump, the fact that I can command it to happen and see an amperage rise tells us power and ground back here are fine. At least they're fine right now while we're testing it. It would help to know from Pete, from the customer, about the situation with this, but I think we're pretty much done. And I hate that kind of ending, but I'm not going to tell him to put a part in it. I mean, honestly, if I'm working in a shop and I have 20 other cars to do, I'll probably want to warranty this part, just because we've seen this before. New parts going bad, and the symptoms are there for this issue. Other than that, I'm not putting a fuel pump in it on a guess. Look how rusty this thing is under here. You think that tank's gonna come down? You think them straps are gonna come off without breaking? Nope. Not here in the Rust Belt. An intermittent is not what I hoped for. That pump is singing right now at this pressure, but it's able to hold it. I mean, it sounds kind of bad, but it's like, I don't want to kill the pump and be like, oh, there you go, bad fuel pump, as I'm jacking the pressure up so high. Now, they have relief valves, so what you're hearing in there is fuel overcoming the pressure relief valve, and what you're hearing is fuel spraying inside of the tank. I know these have pressure relief valves for this reason, but I don't want to do that, to the point where I'm like, hey, bad pump. Yeah, because you killed it. One more test drive and then we're going to wrap it. I'll at least offer you guys that. And then from there, hopefully you learned something on electronic returnless fuel systems. I got more videos on this that we can link for you guys here. Yeah, this is the way it goes sometimes. Let's go for one more ride. All right, we're prepared. I brought my case with me. I brought the screwdriver with me for a tap test. I have test leads with me. I got my phone. We are prepared if this dies. I want it to. I hope you guys are getting that we're literally hoping to break down on the side of the road somewhere. That's what we're hoping for. All right, so you guys know what we're looking for here. Again, fuel rail pressure. And then you're gonna see it right away. You'll start seeing, I'll just leave everything else alone. You'll start seeing the short-term fuel trim go positive when we start losing fuel pressure. I'm anticipating us losing fuel pressure. What we don't know is the cause yet. We don't know the cause. We are prepared as much as we can be. This is a great example of why we charge diagnostic time. What do you mean you're charging me diagnostic time? Well, Mr. or Mrs. Customer, let's go by the code list. What part you want to change first? You want to change the map sensor? Okay. You want to change the fuel rail pressure sensor? Okay. You want to change the fuel pressure module? Control module? Okay. Want to change the fuel pump? What if you change all of those and it's still doing it? Who's paying for that? You are. Customer is. Thousands of dollars of wasted parts thrown at cars every single day. And some of it has to do with not blatant rip-offs and not technician problems and things like that. Some of it has to do with garages not properly billing for this stuff. And it's a waste of time for a garage. A garage right now has 20 other cars he's got to work on. He's making no money on this job right now. What's going to make him money? What's going to make him money is going to be to guess at this problem and replace a part, cross his fingers that fixes it. And the reason that route is picked is because the customer does not want to pay for diagnostic time and the garage does not know how to charge for it. There's just variables upon variables, right? What do you do in this case? What if you can't duplicate the fault? Are you working for free then for the the hour that you put into this trying to duplicate it, 2 hours you put into this trying to duplicate it, should we not charge for that? As my time's being pulled away from other cars and I can't do them because I'm focused on this. So then because I can't duplicate it, then I feel like inside I can't charge because I can't duplicate it. I think that's wrong too. That's wrong too. Should be charging anyway. Customer will bring it back when it happens more often. You continue from there. And it isn't free when they come back. You continue your diagnostic charges. We're doing the best we can. I don't work for free. This working for free crap is why so many technicians leave this field, is this area right here, what we're dealing with right here. Can't duplicate this fault. Oh, I can't charge for it. What do you mean you can't charge for it? So if the garage isn't charging for it, you guys got to understand as customers, guess what? The technician's not getting paid. No wonder the technician just wants to do brakes and tires and suspension work, because every one of those jobs he's getting paid for. This one he's not. He's got to have the most smarts, the most background knowledge, the most training, the most technical aspect of the field is this. And these guys don't get paid like the brake and suspension guys do at the end of the year. It's crazy. It's going to be one long rant here, isn't it? Sorry. Our field needs help. I don't have all the answers, but I can definitely point out a lot of the problems. Can't break this truck though, can we, Caleb? I don't know what to do. Oh, I pulled up voltage. No wonder you guys are probably like, that whole time you're looking at voltage. Let's look at pressure. It's okay. Wide open throttle. No problem. Pull up one of the O2s. See, that run was rich the whole time. Wide open throttle run. Rich the whole time. We're gonna give this back to Pete. All right, guys, so this thing runs beautifully. There's really no reason for me to clear these codes. It's not gonna help me any further. Actually, as I'm getting ready to close this out, there is one more thing that I can maybe show you, is the freeze frame data. Let's just see. This won't really matter, but if they give me fuel rail pressure, we might be able to see a freeze frame data capture that shows the fuel pressure being low. Let's see what, okay, so this is, of course, this is the stuck rich O2. That's the only one there. That sucks. Bank 1 sensor 1 is at 0 volts. Oh yeah, short-term fuel trim is 53% on bank 1. All matches the lack of fuel. Where's the 2102? Long terms look good. Short-term S1 is 53%. See, they're both, that's misleading. O2 sensor signal biased, stuck rich, bank 2 sensor 1, biased stuck rich. That's very misleading. Look at the fuel trims on both banks. 53% on both banks. O2 sensor bank 1 is 0. Where's my upstream bank 2? Let's see. It's not giving me the bank 2 sensor 1 O2 sensor, but that really answers that question for us earlier, which is this rich code. How are we getting a rich code? It's not a rich code. Basically what it's telling you, it may say that in the flowchart too, O2 sensor signal biased. It says stuck rich is very misleading. It's not stuck rich. This is a lean condition. When you see 53% on bank 2, 53% on bank 1, that's the computer adding fuel for a lean condition. Sure, bad O2s can do that, but that's not where we are. It's not where we are. Look at the O2s they are giving me. Those are lean. Upstream and downstream on bank 1, full lean. Let's see if they give us fuel rail pressure. Probably not, because this is global data. So our fuel rail pressure is not going to be in here, but it's going to be the one that would really help us. Nope. This is relative fuel pressure. I'm not sure that I can use that. Relative fuel pressure might actually be the desired on what it wants it to be and not actual. I'm not totally sure on that number. Engine speed's at 800. This was basically at idle. Yeah, that one's misleading, this relative fuel pressure number. But that could have been the moment where it came back to, you know, you have a condition, flags the code, and these freeze frame data captures aren't perfect. Didn't help us really at all. probably, if anything, added more questions with that relative fuel pressure data parameter. Even if that is actual, doesn't change anything for what we're doing. Intermittent fault, can't duplicate it, can't make the call, and I'm not going to. Should we charge for this stuff? Absolutely. I think we ranted about that enough. Hopefully I have an update for you guys. We're done for today, and if anything, I'll try to put something here at the end on what Pete ended up doing and how long the customer drove it. Anything more than I can provide for you, I will. If you don't see anything beyond this point, then we just didn't hear anything back from them. So we'll do the best we can. Guys, we thank you so much for joining us. If you have additional questions on fuel systems like this one, I have lectures on this design. I have more case study videos on this design that we'll link here for you guys. We have training that's available on my website, ScannerDanner.com. I have a book that I wrote, all this stuff, years and years and years of doing drivability that I put together for a class to train the masses, and that's what we're doing. We're in 140 countries now, people that are using my training material, and they're having great success all over the world. So we hope you guys do too, and we thank you for joining us. We'll see you next time. So one more piece, I was just talking to Pete. I wish I would have recorded this because it was really good to emphasize you can't change parts based on a code. Here's what we know about this truck, what it doesn't need. It does not need both oxygen sensors. We had 2 codes for that. It does not need a fuel rail pressure sensor. We had 2 codes for that one. It does not need a map sensor. None of those. Doesn't need any of that. I thought that was important to add in this process. You can't change parts based on a code.